Welcome to AB Calculus, and I'm Mr. Dobner, and I just want to say very much looking forward to working with you later on this semester. You had a summer packet that really is just pre-calculus and algebra review. It's so important for a calculus student to have a good command of that content. Something that you'll hear calculus teachers say over and again is that calculus is really 80% algebra. And really, this packet is designed to help get your skills up. And just wanted to touch base on each of these little sections in the packet and see if there are some things that might prove helpful. The first part of the packet is based on factoring. And I'm not going to be doing problems from the packet, but I'm going to do some problems that are relatively similar to them. And when it comes to factoring, I think the one thing that we should always be aware of when we're factoring is we should always look for a greatest common factor first. Uh, whatever expression we have, we should pay attention to each of these terms and see if there's something in common that can be taken out. Now, here are two groupings. We've got z cubed u to the fourth in our first term. Our second term has a z to the fourth u to the third. You might wonder if there's something that we could divide out from them. Well, both of them have a z in them, z to the third and then z to the fourth. I'm actually going to factor out or divide out z to the third. I can only take 3 z's away from my first term. I can't take 4 from it. Similarly, as I'm looking at my terms with u's, I have u to the fourth and u to the third. In a very similar way, we can say, well, that second term only has 3 u's that I could take from it. So being able to factor out terms from both, I can factor out z to the third, u to the third. What would remain? Well, in my first term here, I've taken all 3 z's away. I'm going to take 3 out of the 4 u's away, leaving me with just 1 u remaining. I'll say plus. As we go to the second term, I had 4 z's, but I'm going to take 3 of them away. That leaves me with a z, and I factored out all 3 u's. This would be the factored form. You could always redistribute, remultiply that in, and double check and see if that makes sense. Let's take a look at another problem here, something that's maybe a little bit more in style to some of the problems that you're going to see. So very often you'll see trinomials. But before we begin factoring any of this out, we of course should pay attention to a greatest common factor. Ask yourself if there's something we could divide out from all 3 terms. In this case, there isn't. What you will see very frequently with trinomials is we'll break that into a product of binomials. You could say, is there a way to multiply to w to the fourth? Well, we might notice that w squared times w squared would accomplish that. When it comes to the trinomial factoring, though, the term in the middle is what we're going to be adding up to. We'd like to have 2 numbers add to our negative 4. This last number here, the negative 45, we're looking for 2 numbers to multiply to that. So we're going to see if we could simultaneously find 2 numbers that would multiply to negative 45 and would also add to negative 4. Well, just giving a little bit of thought, thinking about what numbers might multiply to 45, you might think of a 9 and a 5. 9 times 5, in fact, will multiply to a 45, and 9 and 5 are 4 units apart. If I were to make the 9 a negative and make the 5 a positive, negative 9 plus 5 would be negative 4. And at this point, we would be very tempted to stop. However, whenever we have a difference of squares, a subtraction of squares, we can continue factoring that and that would factor down to w plus 3 and w minus 3. You might remember the difference of squares factoring. A squared minus b squared will always factor into a plus b times a minus b. So that's as far as we can go. W squared plus 5, as soon as we see that addition in there, w squared plus a number, you can't break it down any further. You couldn't factor it, even if that 5 was really a perfect square. Okay, let's take a look at another problem that I think is a very good one to review, and that's a problem that might look a little frightening at first because it seems longer. You can see instead of having 3 terms called a trinomial, which we would have had before, right now we have 4. And at first glance, you look at this and think, oh my goodness, can we break this down? Indeed we can. What you'd like to do is actually just focus in. When you see these 4 terms, see if we could do something called factoring by grouping. Now, factoring by grouping means that just looking at these 2 terms, see if there's a common factor that we could divide out just from these 2. Well, let's see, I have a 4x to the 4th minus 7x to the 3rd. A 4 and a 7 don't have a common factor other than a 1. However, what you can do very quickly is notice that x to the 3rd is going to work out. So I'm going to actually factor out x to the 3rd, and then this would leave us with 4x minus 7. Now I'm going to look at the other 2 terms, and specifically the 8x minus 14. You might wonder if there is a common factor there that we might be able to factor out. There is. We could actually divide out a 2, and if we did that, you would see that we would be left with a 4x inside, then minus 7. Now, something to notice here, sorry, I used too thin of a pen originally. You'll notice that we had 4x minus 7 in this other parenthesis as well. Look at this, the 4x minus 7 and another 4x minus 7. Imagine if, just for a moment, a side note, imagine if I gave you x cubed w plus 2w. If you saw that, you would probably, hopefully, factor out a w. Say I could undistribute a w from that. Well, that's all we're going to do right here. We're going to undistribute that w, but the w is really 4x minus 7. So I've got 4x minus 7. I'm going to pull that out, and then we're left with x cubed plus 2. This is called factoring by grouping. One last one that I'd like for us to take a look at today. For example 4, let's review factoring a difference of cubes. What if I gave you a to the 3rd minus b to the 3rd? Hopefully you remember that factors into the following formula. A minus b multiplied to the quantity a squared plus ab plus b squared. And what I'd like for us to do is take a look at factoring 64 u to the 3rd minus 27 w to the 3rd. And sometimes this problem might seem to be a tad more challenging. What I'd like for you to do before you do anything, though, is see if you could find out what it is exactly that's being cubed. What number times itself 3 times? What number raised to the 3rd is 64? Well, hopefully without too much work you could find that it would be a 4. U to the 3rd, well, I hope you can see it's simply u raised to the 3rd power. 27, well, my goodness, what number raised to the 3rd is 27? Hopefully we'd see that that would be a 3. Now I'm pointing this out so that we could very quickly notice that our 4u is really our A. And our 3W is really our B. And if we remember that, we're going to be in real good shape. So this is our A, this is our B. And following this formula, we could say, well, I need A minus B. Well, I'll need 4U, that's my A, minus B, well, that's 3W. And then we're going to say, well, now I need to multiply by A squared. Well, if A was 4U, square A, 4 squared is 16, then we'd have 16U squared. We'd say plus, now what would A times B equal? 4U times 3W would be 12UW. And finally, we could say, well, what about B squared? Well, if B is 3W, when I square 3, I'll get 9. Square W, I'd get W squared. So this would be how to use the cubic formula to factor. Really, we're going to stop right here, and like to continue to make these videos. I hope they're going to prove to be helpful to you. In some cases, we're going to do a little combining of some lessons when they're a little bit shorter.